Hi guys, my name is Jack from First Robotics Competition Team 1736, and today I'm going to be talking about gear ratios using this LEGO Mindstorms robot. So as you can see, I have a little motor here with an arm right over here that connects to the motor by these two gears. Now you've probably seen gears before, and you may have wondered what exactly their purpose is, besides just maybe connecting a motor to the thing it's actually turning, if the motor is far away from the actual arm it's turning. However, gears have a lot more important use than you might think. So let's go ahead and spin this gear for a little bit. So as you can see, the arm moved. It went pretty fast, but it was, just a moderate kind of speed. But what if we wanted to make that go faster? Now, one way we could do that is we could increase the power that the motor is giving. However, there's a much simpler way to do this, and that is with gears. By changing what we call a gear ratio, you can actually increase the speed or even decrease the speed of your motor output to the actual arm itself. Let me show you what I'm talking about. So right now, both these gears are the same size. And that means they have an equal gear ratio, which means that they have as many of these little teeth here on each gear. And so if you think of a ratio, which is basically the same thing as dividing two numbers, one number on the top, one number on the bottom, with a line in between them, they're both equal. So when you divide that out, it equals 1. But if we wanted to change that, we could actually put a smaller gear on either the actual point that connects to the motor or on the point that connects to the arm. So if we wanted to make the motor go faster, we could actually connect it to the port that goes on the arm. And you may be thinking, why does that make it go faster? Well, let me demonstrate. Alright, there we go. So now you can see that we have two gears that are different sizes. On the part that connects to the motor, we have a bigger gear, and on the part that connects to the actual arm, we have a smaller gear. Now, let's demonstrate how this goes. So as you can see, the arm definitely went a little bit faster there. But why did it do that? To explain simply, we have a big gear next to a small gear. Every time this big gear rotates once, it'll actually make this gear rotate more. Because if you think about it, there are less teeth on this one and more teeth on this one. So that means that by the time this one goes around, it's going to have to go through more teeth than this one has. Back when we had this gear, it only took one full rotation of this gear to go through one full rotation of this gear. But now that we have a smaller gear, for every one rotation of the big gear, there is multiple rotations of the small gear. And you might be able to look at this. So if I kind of slowly spin this, as you can see, this part right here is spinning. Alright, so we're about halfway. So we're about a quarter of the way there. Now you can see, we're only about a quarter to a half away through the rotation of this gear, and this gear is only spun once. So if we keep going, alright, now we're at half, 3/4 of the way through, and now we are back to our original spot, which was this one right here. So as you can see, that is actually more than one rotation on this one for every one rotation. I think it was about maybe 1.5 rotations. So as you can see here, because this gear spins more per rotation of this gear, that means that this arm is actually going to go faster every single time, because unlike this one where it was just going the same speed, this one has to go faster because there's less teeth on this gear. And so we go from a result like this to a result like this. So you may be thinking that's pretty cool, but what would happen if we flip-flop these? What if the bigger gear was on this end and the smaller gear was on this end? Well, let's take a look and see. Alright, so now as you can see, we have the smaller gear attached to the motor port and the larger gear attached to the arm port. Alright, let's see what happens. So as you saw there, the arm actually went slower than not only the fast gear ratio, but also the neutral gear ratio, where we had both these big gears attached to each other. So why is that? Well, it's the exact opposite effect of the big gear to the small gear. For every rotation of the small gear, the big gear is not able to complete a full rotation. And so, at the same speed, that causes the arm to actually go a little bit slower because it's not able to rotate as quickly because this gear is not able to rotate as quickly. And you may be thinking, what's the purpose of a slow arm? Wouldn't you want a fast arm? Well, it actually creates something different, and that's a concept called torque. Now, you may not have heard of torque. It's probably less commonly known than speed. But torque is kind of a complicated way to say strength. So this arm is actually probably able to lift a lot more weight than our previous two gear ratios, the one with the equal gears and the one where the large motor, or the large gear, is attached to the motor and the small gear is attached to the arm. So if you're wanting to lift a big heavy object and you're not really concerned about how fast you want to lift it, you can use a gear ratio like this in order to lift that object up easier. It's a lot less stress on the motor. And that's kind of what it all boils down to. It's a simple way to use simple tools like this in order to not strain your equipment as much. If we wanted to make our gear ratio go faster, we would have either had to use the gear ratio like we used, or we would have had to increase the power of the motor, which over time, if say you're using a battery or fuel, would take up more fuel or power. However, with the gear ratio, you're using the same amount of power, but you still get that increased speed that you want. Same with this one. If you wanted to use more strength, if you wanted to lift something heavy with just a single motor, that would strain the motor more and cause the motor to wear down, causing it to deteriorate quickly. However, if you use this simple gear ratio here, you're able to prevent that strain on the motor and just simply be able to lift more with a simple change in gearing. So, remember, whenever you need more speed or strength, always try to go for a gear ratio instead of trying to strain your motor. Thanks for watching, guys. If you guys want to learn more about Robot Casserole or FIRST, check out our social media and our YouTube page at FRC1736. Until next time, see you guys.